Quideo number 5, basic question, gives us a data plot showing us the daily intakes of calcium for 38 women between the ages of 18 and 24. Part A asks us to display the data using a histogram and then describe the distribution of calcium intakes for these women. So this is my graph of calcium intakes. The X is the calcium intakes, and it starts at 300 and ranges in increments of 300 and ends at 2700 milligrams. And the Y is the number of women in each section. And the distribution is skewed right. Part B asks us to find the mean, standard deviation, and standard error. So by inputting these numbers into my calculator, I found that the mean was 926 milligrams, the standard deviation was 427.2 milligrams, and then standard deviation, by taking the standard deviation and dividing it by the square root of n, was 69.3 milligrams. Part C asks us to find a 95% confidence interval for the mean. So to set it up, it is 926 plus or minus t star, which is 2.042, times 69.3, and that will equal 751.9 to 960.5 milligrams. So we are 95% confident that women between the ages of 18 and 24 will have a daily calcium intake of 751.9 milligrams to 960.5 milligrams. Part D asks us to eliminate the two largest values and then redo the 95% confidence interval and to say what we notice. So using the new data, we find that the mean is 856.2 milligrams and the standard deviation is 306.7 milligrams. And again, taking the standard deviation and dividing it by the square root of n, we get 51.1 milligrams for the standard error. So for the 95% confidence interval, it is 856.2 plus or minus 2.042, that's t star, times 51.1, and that equals 751.9 milligrams to 960.5 milligrams. And this means that we are 95% confident that women between the ages of 18 and 24 will have a daily calcium intake of 751.9 milligrams to 960.5 milligrams. Something we noticed was that it has the same range as Part C did, where it did have the higher values still included. Quideo 5, advanced question. This one deals with probability. So you play two games against the same opponent. The probability of winning the first game is 0.4, and if you win the first game, then probability of winning the second is 0.2, but if you lose the first game, then the probability of winning the second is 0.3. Part A asks if the two games are independent. So they are not independent because depending on what happens in the first game is it will determine the probability of winning the second one. Part B asks what is the probability that you lose both games. So the probability of losing the first is 0.6. The probability of losing the second game, saying you have lost the first, would be 0.7. So we multiply those together and we would get 0.42. Part C asks what is the probability you win both games. So the probability of winning the first game is 0.4, and if you do win, then the probability of winning the second is 0.2. So we multiply those together and we get 0.08. Part D asks us to make a probability model for X, and that's what it is, just showing the value and probability for each one. And then Part E asks us what is the expected value and standard deviation. So how we do that is we take the value and multiply it by its probability, each one, and then we add those together. So 0 times 0.42 would be, or 0.42 would be 0, and then 1 times 0.5 would be 0.5, and then 2 times 0.08 would be 0.16, so we're left with 0.5 and 0.16, so we get 0.66. For the standard deviation, we have to take the value, subtract the expected value, and then square that number, and then multiply it by its value for each value, and then add those together. And after that, we square root it. So doing that, we get 0.62. Quideo 5 AP question is trying to compare two methods of determining the level of E. coli bacteria contamination in beef. And they give us a graph showing us the values of E. coli from each sample and using each different method. And they ask us to tell if there's a significant difference in the mean amount of E. coli bacteria detected by the two methods for this type of beef. So the parameter is the two methods of detecting E. coli bacteria being used and tested against each other. The HO is the mean difference equals 0, and the HA is the mean difference does not equal 0. Mean difference is the mean difference of results by the methods of determining E. coli. We find normality by inputting the differences of each method and then graphing them using a histogram, which shows normality, and we can assume independence. Now we use a paired t-test, which is x bar of difference minus 0 over standard deviation of difference over square root of indifference, which would actually be 0.29 minus 0 over 0.6297 over the square root of 10. We found the mean values and the standard deviation value by going to the Wormvar stat test, which gives us a mean of 0.29 and a standard deviation of 0.6297. So this t-test gives us a 1.46 back, and using a 9 degrees of freedom, and we get a p-value between 0.05 and 0.10. And at the alpha value of 0.05, we fail to reject the HO of mean difference equals 0 due to that p-value being possibly greater than 0.05. This means that there is not significant evidence to say there is a difference in the E. coli tests. Thank you.